you ever thought about what it would be like to have a career at NASA? What do you think you would be doing? This year, COSI is partnering with NASA to highlight some of the many different career paths available. Join us as we hear from experts who are willing to share a little bit about their careers with us.
Hi, my name is Jonathan Drexler, and I work at the NASA Glenn Research Center in Cleveland, Ohio, and I'd like to talk about what I do at NASA. I studied mathematics in school, and a key part of my job is to estimate how much an instrument, rocket, or spacecraft will cost. It's actually different for each one. Did you see the Perseverance rover that landed on Mars on February 18th of this year? That mission cost $2.4 billion to build, launch, and land on Mars. To understand just how much $2.4 billion is, let's start with a single dollar and work our way up. A single dollar measures 6.1 inches across. If I place $2 bills end to end, they start to form a line. If I place 1,000 $1 bills end to end, that would measure 512 feet. That's longer than a football field. And if I place $2.4 billion end to end, that's almost far enough to stretch from the surface of the Earth to the moon, but just come a little short. Let's talk about the first two characteristics that affect a mission's cost: mass and complexity. Launched in 2014, my first example is PhoneSat 2.5. Its mass is about 2 pounds. It's called a CubeSat and is small enough to fit in your hand. Its complexity is pretty simple. Its mission was just to test using cell phone electronics in space. So overall, its cost is going to be pretty low. Now, let's go back to the Perseverance rover. Its mass is about 2,260 pounds. That's as much as a small car. And its complexity is very complex. It has special cameras that are taking pictures of the surface of Mars. It has instruments testing for signs of life on Mars. And it's a rover, so it gets to drive around another planet. Altogether, that means its cost is going to be much higher. The next mission characteristic I'd like to talk about is a mission's destination, where it's going in space. Although rockets make it look easy, it's actually really hard to get to space. It's less expensive for a mission to stay near Earth, or what we call Earth orbiting. If you're going to travel far from Earth, we call those missions planetary missions. Planetary missions need a lot more extra energy to escape Earth's gravity. That means bigger rockets. Bigger rockets mean more money. It also takes a long time to travel far in space. Just to get to the moon would take 3 days, traveling all day and all night. And if you were to travel as far as Jupiter, that could take up to 6 years. And you know what they say, more time means more money. The last characteristic I'd like to talk about is whether a mission is robotic or human-rated. Now, when I say robotic, I just mean that it's a complicated machine. But when I say it's human-rated, that means astronauts. You can think of NASA's programs like Space Shuttle, the International Space Station, or the current Orion program. And just like on Earth, astronauts need air to breathe, food, and water. And those missions have to take everything with them. And when the astronauts are all done, we have to return them safely to Earth. Altogether, that means those missions can cost a lot more. And how do I do my job? NASA actually collects data on every mission. My job is to go in and analyze that and use the math and statistics that I learned in school to help NASA better plan for the future. If you go to NASA's website, you can actually find out information on all NASA missions. You'll even find information on the power propulsion element, which is being managed by Glenn Research Center. I love my job because I get to use all the math that I learned in school, and I get to work with all types of missions across NASA.
Thank you to the experts at NASA for sharing insight into their careers, and be sure to check out today's COSI Connects activity.